Hey, George, you're a scientist.
I'm a chemist, yes.
Yeah, you're a scientist. So, what makes stainless steel stainless? And is that different from like Damascus steel? Like, why steel? Like, can you even have not stainless steel? I don't think I've ever seen a steel product. Like every butter knife says stainless on the side. Like, what makes it stainless?
Darn it, Lions. I am a chemist, not a metallurgist, but with my very limited expertise and very limited knowledge set, I will attempt to answer this question. So let's start with what is steel?
So, I think steel's an alloy
It is.
because
Yep.
it's there isn't steel on the periodic table, so it's not a pure element.
Nope.
And I think it's iron and I want to say carbon.
Yeah, man. Circle gets the square. Got it in one.
Hey, it's
Iron
because
and
I've watched
carbon.
documentaries about swordsmithing.
Yeah, so carbon, I think it's normally about 2% carbon, and that makes steel, which is stronger than just iron is by itself. So stainless steel. So to your point, right? It's like, is there such a thing as non-stainless steel? Yeah, sure. I mean, there's tons of it, right? It's just um, the my understanding is that the process for making stainless steel, like the additional metals that are used in the alloy, are not super expensive, right? So it's like, why would you make something that's going to automatically fall apart when for an extra dollar you can have a thing that will last forever, right? Um, so what when we talk about steel staining, what are we kind of talking about, right? Because like stainless steel will get hard water stains on it, right?
Yeah,
So
I
like it's not stainless,
I assume they actually mean that it won't rust
right?
because
Exactly.
iron oxidizes, right? Which is
It
what rusting
does.
is.
Yep.
Okay.
Yeah, man, dude, you're on it. Do you need me here? I can head out.
I mean, I could say more words. They would not be as scientific as your words.
we're we're getting like the error bars get larger and larger the longer you go.
Yes, exactly. Yeah, we both are saying how to get to the restaurant, but you live here and I've been here once before.
And it just cuts to the end of the episode, and you're like, and so that's how George Washington faked the moon landing. And like, how did we get there? It's like, I don't know, man. I just kept saying stuff, and the error bars kept getting bigger. So stainless steel in particular is steel that is alloyed with another metal. It can be molybdenum, carbon, nickel, nitrogen, but mostly chromium is the
I
main one that they alloy it with.
I'm sorry. Is nitrogen technically a metal?
No,
Okay, so I just misheard you. That's fine.
no, I said nitrogen. Yeah.
Yeah, but you said alloyed with another metal, and then
Oh,
nitrogen was
yes.
on the list.
Oh, sorry. Yes, nitrogen is not a metal. No,
Okay, good.
it can be alloyed with other substances. Excuse me. Um, yes. So chromium typically being the big one, where it's most stainless steel is 10.5% chromium. So here's kind of an interesting.
Isn't chromium super cancerous?
Haha, you got there before me. That's awesome.
Okay.
Yes. So chromium isn't. Hexavalent chromium is, right? And this is the thing that I think is just so fascinating to me about like chemistry, where it's just kind of like, oh yeah, I found some chromium in my water. It's like, be more specific, be way more specific, because hexavalent chromium was like, oh no, like you got to get that taken care of. Trivalent chromium, it's like, oh, drink more of it. That's good for your digestive tract, and it's like metallic chromium, and you're like, that probably tastes gross. But so yes, hexavalent chromium is the stuff from Aaron Brockovich. That's the stuff they were
Yes.
hunting down. So some other things that are worth noting that I thought was kind of cool as I was researching this is that stainless steel has a biological cleanability greater than aluminum or copper. It is actually comparable to glass with how well you can clean it and sterilize it against biologics.
Is that why people just throw around the term like surgical steel?
Yep. Yeah, because it's like it's got to be stainless steel. You can autoclave it. You can do all this sort of stuff, but like its ability to get like microbes actually embedded into the material to where like you can't really clean them off is similar to glass. And I'm like, oh, that's kind of cool. It's super cleanable. So, as you mentioned, the thing that makes steel stain is that iron famously oxidizes, right? And so, what does iron look like when it oxidizes?
You get like that kind of red, right? It looks like Mars, right? It's like the orangey, reddy, rusty color.
Yep, exactly. And if you kind of like rub the rust, it gets all gross and on your hands and stuff. Well, so that's kind of the problem, right? Is that when you rub it, it flakes off, right? So as you continue to rub it, it will continue to flake, which then exposes newer layers of iron to then become oxidized, right?
Right, because the oxygen won't permeate into the iron. But as soon as you're like, oh, I'm going to buff off this little bit of rust, you've now given fresh new iron exposure to the air.
Yeah, exactly. So like the iron that's like 5 layers deep is just completely dark, no light can hit it, and all of a sudden you rub off a few layers and it goes like, oh my god, the sunlight, everything's great. Oh god, oxygen, oh no. And so and then it all goes sideways. So basically is that as you rub off the layers, you continue to expose more iron to rust. And one of the other reasons why rust does that, right, is because if you've got a block of iron, it does this kind of cool thing where a block of any metal, where it does what's called metallic bonding, right, which is that all of the metal nuclei are like right next to each other, and they just share this vast electron cloud, right? So if like if you were to use an analogy, right, where it's just like ionic bonding is like late stage capitalism, where like the one thing has all the electrons, right, and the other one gives up its electron, right? It straight up gives it up, right? And so you have then dipole bonding, right, covalent bonding, where like some of the electrons given up, right? Metallic bonding would be pure communism. We all share all of the electrons, right?
So I'm going to sneak a sub question in here, because I remember hearing maybe in like a science fiction movie or something that like if you had like pure iron, like a cut piece of pure iron, and you pushed it against another cut piece of pure iron in a vacuum, like in space, that they would fuse because they just don't know like where the iron stopped, and it would like become a whole piece of iron again because there's no contaminants in space, right? So like that always sounded like one of those things where I was like, that's really neat and maybe not true.
That doesn't sound right, but I think that there is something called like cold welding, and I forget how that works, but that'll
be another episode.
Yeah, there you go, right? How does cold welding work? And if I take 2 pieces of iron in space and press them together, will they form?
That will be the real question.
Yes. Yeah. That will be the question, and then I'll talk about So the cool thing. Oh, so what I was going to say is with metallic bonding is that the reason why it kind of flakes apart is because oxygen screws all of that up, man. The oxygen just comes in like a giant pockmark on this like beautiful, like even electromagnetic cloud. It comes in and goes like, hey, I get electrons too. I want yours. And oh man, me and this iron, we're iron oxide. The rest of you are not iron oxide. We're cool and we're the new hotness. And you guys should all be paired up with iron oxide too. And woohoo, let's flake off and be our own thing. Yay. And then it's not part of the collective anymore. So that's why iron oxide isn't cool, man. So but one of the cool things is that chromium, so the idea is it's like, well, does chromium obviously then doesn't oxidize, right? Because like we don't see that iron. It does though. But the difference is that chromium oxide is way cooler, right? Like it's like chromium oxide is the relationship where it still lets you have friends, So like what it does is it oxidizes and then stops and it becomes inert, right? But it also stays on top of the metal, right? So as the chromium oxidizes, it just kind of like sits still and creates almost an inert protective barrier over the rest of the metallic piece, right? So and so then it as opposed to flaking off and then exposing more of the steel to oxidizers, it just stays put and is oxidized already. So there's nothing to react with.
So does that mean that the part of stainless steel that makes it stainless is more like a coating than like it, or is it actually mixed into the metal? Like if you had like a stainless steel butter knife and you broke it, would the exposed part be able to rust?
So it is my understanding that it is not a coating. It is actually an alloy, right?
Okay.
It's just that so in theory, if you broke, and this is an experiment I could do, um, if you broke the stainless steel spoon, right, and you dunked it into water, right, and then just waited, it should still be stainless throughout, right? So the idea is that for whatever, and this is where I'm not as specific on it, is that the ratio of about 10 to 12% chromium is such that it allows that when it oxidizes and potentially the iron would oxidize as well, it keeps everything locked into place, you know? So like the top bit of it does oxidize, but it is able to keep its strength, you know? Structural integrity. That was the word I was looking for.
You got there. So this is is there like a range of stainlessness then? Like if you have
oh yes.
Okay, so how does that work?
It's based off of the different levels of different types of metals that they use and how much of the alloy they put in. But yeah, as I was looking it up, there's a whole bunch of different types of stainless steel. Like it's not like, oh well, it's one scale. I mean, there was like 3 different names, and then they had different names and numbers. Like it's something where I feel like that if you know that stuff, it's because it is instrumental in how you do your job, right? Because like at one point they were saying like, oh, well, you can use some stainless steels with like certain acids. I'm like, metals famously corrode in acid, right? Like that's what when we analyze for metals, we put them in acids, so like to digest them. So the fact that they have stainless steels that are stainless enough that they can use even dilute acids, right? I was like, oh, that's kind of cool. And then there was a picture that said like, you see, even some stainless steel can rust over time. And like it showed this giant thing and like a small pock like on the thing. And I was like, again, I assume that for whatever process this is in, that now makes this thing worthless. But yes, I mean, I'm still impressed. I don't know. Still seems pretty stainless to me.
Yeah, I guess this is like if you are making a butter knife that's going to be used in a Waffle House, probably have like a different standard of success and how much failure you would be willing to accept if you're making like pylons that hold up like an oil rig, right? That will be submerged right. in salt water all the time. Like you need probably different stainless steel than your dive bar butter knife.
Yeah, exactly. And as with all things, right? It's just like, well, why don't we make it all out of the highest one? It's price, Yeah. It's like, well, do you
why doesn't the Waffle House have fine China?
Whenever I go to you and I say, I want a new computer, and you say, well, I have follow-up questions because like, well, what's the best one? It's like, well, what are you trying to do with it? Because if you're trying to, send someone to the moon, you can just do that on your graphing calculator. But if you want to play video games, well, then you need a serious engine, right?
Yeah.
Because we've got our priorities straight.
We do. But I think for the first time so far since we've been recording these, this very episode made me think of another question I wanted to ask you.